Welcome to VW 2.4. We're going to start with a couple examples here. This first one says find the average rate of change. So this is a concept from last semester, maybe last quarter. Hopefully you recall that this simply means to find the slope. So it gives us a function, the sine graph, and it says from 0 to pi over 2. So what we got to do is find the two coordinates. We got to figure out what is f of 0, what is f of pi over 2. So plug in 0, and sine of 0, as we know, is 0. And plug in pi over 2, you get 1, which means the two coordinates are 0, 0, and pi over 2, comma 1. Now let's find the slope. So that would be y1 minus y2 over pi over 2 minus 0, or x2 minus x1. That's 1 over pi over 2, which means their slope, or average rate of change, is 2 over pi. Let's do another example here. Same concept. We're going to plug in f of 0 and f of pi over 2, except it's cosine, so cosine of 0 is 1, cosine pi over 2 is 0. So the points are kind of inverted, but it's the exact same process. 0 minus 1 over pi over 2 minus 0, that's negative 1 over pi over 2, which is negative 2 over pi. So there's our average rate of change problem. No problem. Now I'll take a look at this. Hopefully we remember this from last quarter. This is a composition. This is f of g of x. This is g of f of x. So for 79, let's first calculate f of g of x. So you plug in g into f. That would be sine of 4x. And it says to graph this, so that's no problem. I can see my amplitude is 1. My period is pi over 2. And let's just graph it like we always graph things. Here's our sideways t. Our amplitude is 1. The period is pi over 2. So we'll just continue labeling here. And we graph our sine wave. It's a really simple application of an old concept. And recall that these two things, the concept is composite functions. It also says find g of f. So let's write g of f. So I take f and plug it in. So that would be 4 sine x. Now same concept, a is 1, period is 2 pi. And notice how I do the same thing. We just got to graph it. So 0, a is 4, so put 4, negative 4. Fourth tick mark is 2 pi. So we scale appropriately. And let's sketch our wave. Okay, now for the final example. This should look familiar. Another old Algebra 2 concept. Hopefully we remember. This is called a piecewise function. Now to do this, it's going to be a little tricky. It gives us our domain from 0 to 5 pi over 4 and 5 pi over 4 to 2 pi. So let's just start by making our graph. And I'm going to put 1 and negative 1 here, 0. And let's just scale it normally. So 2 pi, pi, pi over 2, and 3 pi over 2. Now the point of interest is definitely going to be 5 pi over 4, because we got to kind of put a fence in where that would be. So I'm going to put a dotted line at 5 pi over 4. So that would be between pi and 3 pi over 2. So I'm going to put a dotted line right here. So that's going to be my separator. So that's going to represent 5 pi over 4. So I know in this section, section 1, I'll call that, that's going to be my sine function. In section 2, it's going to be my cosine function. So let's graph our sine function. So it's going to go like this. And here's the tricky part. Normally sine would continue all the way down to -1 right here, but it gets cut right here. So we're going to have to just stop it right at the point. And then for now, it's open circle because it says not equal to. Now what gets interesting is this cosine graph. Now I know cosine at 2 pi ends at 1 right here. And it would go to 3 pi over 2, so I know it does this. And cosine, again, would normally continue down all the way to -1 and have this line right here. So I know it's going to continue. And notice how it actually fills this hole right here. And again, normally it would go all the way down here. But since it gets cut right here, we don't want that part. So that's gone. So this point of intersection is really nice. This point is going to be 5 pi over 4. And I can just plug in 5 pi over 4 to my cosine function. And that should be -√2 over 2. And there it is. We graphed a piecewise function. And again, notice how it didn't go all the way down to -1. It's stopping just short at -√2 over 2.